Good morning, students. Welcome to your physics class. I hope you are doing good and are in good health. So, let's start with our class. So, students, in our previous class, we have discussed the introduction of graphical representation of motion, right? There we have started our distance time graph. We have made certain conclusions also. There we have also discussed how to find the slope of a particular line. So, tell me how to find the slope of this OA. This will be what? Vertical distance of this right angle triangle and the base distance. So what will I write here? I will write slope of OA is AB upon OB. Now, what is the length of AB? Since we know that AB is parallel to this OC line also, so AB length will be equal to the length of this OC. So OC is how much? 4 meter. Okay, so 4 meter upon OB. OB is of 2 seconds, isn't it? 2 seconds. So what will be my slope of OA? It will be 2. Okay, and this will come in meter per second, isn't it? Since it will come in meter per second, can we also say that it also represent what? It represents speed of a body in distance time graph. That means the slope in the distance time graph also represents the speed of the body, and here we know that the body is moving with a uniform speed, isn't it? So this OA will represent my uniform speed. Okay. The slope of the distance time graph represents the speed of the body. Okay. This is a distance time graph. This is a slope. This slope represents the speed of the body. Okay. Now, mathematically, the slope of any line, here the line is OA. The slope of any line is a unitless quantity. Why? Because it is what? It is the ratio of the two lengths. The ratio of the two length will result in the unitless quantity. It will not have any unit. But here we are not comparing two similar physical quantities. We are comparing two different physical quantities. Here we are comparing change in the position with respect to time. The physical quantities are distance and time, and they both have different units. That's why here meter per second has come. Okay, so in general, if somebody asks you to calculate the slope of any line, then you will not write any unit. Why? Because mathematically the slope of any line is a unitless quantity. Okay, it doesn't have any unit, but here it is representing the speed of the body. That's why it has this unit. Okay, students, here the object has started traveling at t1 second and it has traveled till t2 second. Okay, similarly it has changed its position from small s1 meter to small s2 meter. From now onwards, small s will be used for distance traveled. Okay, or displacement. So this S1 is the initial position where the object was at the beginning, and S2 is the final position. So the object has traveled from S1 position to S2 position. So tell me, students, how much the object has traveled? It has traveled the distance between S1 to S2. Okay, it has traveled 4 meter distance. How you have got this 4 meter distance? It is 4 minus 0. So the distance traveled is what? S2 minus s1, and this distance traveled is in the time period of t2 minus t1 second. So can we write as speed is equal to distance traveled upon time taken? It is what? It is speed is equal to how much distance has been traveled. This is of s2 minus s1. Okay, so this will be s2 minus small s1. Okay, now, and the total time taken is how much? It is between t1 and t2. So what will we write? We will write t2 minus t1. Okay, so t2 minus t1. Final time period minus initial time period. Final position minus initial position. Okay, so speed is s2 minus s1 upon t2 minus t1. Okay, now tell me students, this speed was what? The earlier the speed was the slope, isn't it? So can I write this as slope of distance time graph? Okay, students, till now we have seen the case of uniform speed in distance time graph. Okay, now see another example. Consider the following data which shows distance traveled by a car at regular time interval. Here the table is given to us. Now pause this video and have a look on this table nicely. What have you noticed? You have noticed is that when we see the time interval, then it is of equal amount, isn't it? Every time 2 seconds is increasing. Now if you will look on the distance table, then you'll get to know that here there is a change of +1, here there is a change of +3, here there is a change of +5. So there is unequal amount of increase in distance. And here the time interval is increasing uniformly with equal time intervals, but the distance is not increasing with equal amount, isn't it? That means this is the case for non-uniform speed. Now, can we plot this on the graph as I have taught you earlier also? How will you plot this? On the time axis, you're going to plot 0, 2, 4, 6, 8, 10 and 12, and on distance axis, that means on y axis, you are going to plot 0, 1, 4, 9, 16, 25 and 36. Now, first of all, 0, 0 and then 1 and 2. Okay. Now see, time interval I have divided into 2, 4, 6, 8 like this, and this distance like this. Why? Because it is of the range of 0 to around 36. So I have plotted it from 0 to 40. Okay, and since this time axis is in the range of 0 to 12, see 0 to 12, so I have plotted like this. Okay, when you will plot, first one is 0, 0, so I have plotted like this. Second one is 2 and 1, 2 second and 1 meter, so this is the 1 meter and 2 second. Okay, third one is 4 second and 4 meter. See, 4 second and 4 meter. Next one is 6 second and 9 meter. 6 second and 9 meter. Okay, likewise you're going to plot this. So after joining all the points, you are going to get a curve. Okay, this shows that the object is in non-uniform speed. Why? Because in equal interval of time, the distance is not being traveled equally. Okay, and you are not getting a straight line inclined to the time axis, which was the case earlier, isn't it? You are getting a curve this time. This shows that the object is having non-uniform speed. Now students, to sum up with the distance time graph discussion, see all these three figures. In the first, the body is at rest. This shows that the body is at rest. Why? If we'll get a straight line parallel to the time axis in the distance time graph, then the body is at rest. That means the speed is 0 meter per second. Okay. Now in the other case, if we'll get a straight line inclined to the time axis with certain amount, with certain slope, then we'll say that the body is having uniform speed or constant speed. Okay, and in the same way, if we'll get a curve, okay, in the distance time graph, then we'll say that it is having non-uniform speed. Okay.